Okay, real quick. So for number one here, you need to find your three angles. If you want to pause and work these out, that's great. Otherwise, the first angle you need to solve for is C, because side C is the biggest. Use the law of cosines, take the cosine inverse, plug in your numbers. And if you type this into your calculator, you should get that C is 117.28 degrees. Yay? All right. How do we find angle B or angle A? Law of sines. You could actually use a law of cosine if you want again, but I think that's more work than the law of sines. For the law of sines, we could just, let's do A first. We'll do the sine of A over A equals the sine of C over C, which means A is equal to the sine inverse of side A, 9, times the sine of C over C. So times the sine of 117.28 degrees over 14. Type that in and you should get 26.38 degrees. Yay. Okay, now how would we find angle B? What are these three angles? I mean, I know C is 117, I know A is 26. So how do I find what's left over for B? Yeah, just subtract 20. And again, you could do the law of sines, you could do law of cosines. Really, once you have two, you just do whatever method you like better. But I think the easiest is just subtract, find out what's left over for your buddy angle B. Because the nice thing about angle A and angle C is they'll always leave something over for angle B. Angles and triangles are very nice. They share and share alike. Oh, why am I typing this? The answer is 36.34 degrees. A bit. And then if you spot check your answer, you can make sure that you did this correctly. The largest angle is opposite the largest side. The smallest side is opposite the smallest angle. Angle B is your medium angle, and side B is the medium side. Let's say you spot check and you realize that that is not what worked out. It's probably because, if I had to guess, the most likely error is you didn't solve for angle C first. And then you have to erase all of your work, start over again at the very beginning, solve for angle C first. Questions on number one? Or does anyone need more time to write? Because I'm just gonna have to clear this bottom space. Okay. All right, I'm gonna do number two here. Since I didn't lecture on it before, but the area formula that you should write into your notes is area is 1/2 BC times the side of A. So basically, for any triangle, you don't have to write this down, but for any triangle A, B, C, C, if you know two sides and the angle in between them, you can find the area with this formula instead of having to do anything with like the Pythagorean theorem or anything like that. You can just use this formula. So in this example, I'm given two sides and the angle in between. So if I plug my three numbers into my formula, the area would be 1/2 on 90 times 52 times the sine of 102. Which, if you type in, is, okay, I gotta switch my calculator back to degrees. 2,288.865 meters squared. That's a big triangle. You could fit a lot of circles inside that triangle. So that's it. So for that one homework question, that's all you got. You just plug in the numbers into this formula. You could. Because for a right triangle, that Ty, that's a great question right there. You could get some space bugs. Here is a space bug. Because actually, if you look at this formula, let's say this is a right triangle. What is the sine of 90 degrees? Well, that's your y-axis, right? Sine is the y value, and the y value at that point is 1. So you'll do a half of b times c times 1. A half of 1 is just a half, and a half of b times c is a half of base times height. So it actually is the area formula. But let's say you're not given that, you're given like, let's say you're given like a C, right? Let's say you're given this angle and you aren't given the height, you're given the other two. Yes, it would work for that too. So you're right. The area of really any triangle is a half BC times the sine of A. Great question. You know what, Ty? Here's another space bug. There you go. Don't spend it all in one place. All right. Well, I think you're going to enjoy today because we're going to do some real life problems, some side angle, side stuff, and Heron's area formula. None of which I feel like will be too taxing for you. All right. So far, every problem we've done has given you 3 sides and you had to find the angles. Now let's say that you have 2 sides and the angle in between. You need to find the other side and the other 2 angles. Your instinct might be to use the law of sines when you're given 2 sides and an angle, but it won't work because we don't have a pair that's given, right? Like I'm missing side A, angle C, and angle B, so there's not a pair that I could do the sine of blank over blank and get my ratio. So if you try a law of sines, you'll quickly find that that doesn't work, and then you go, okay, what else can I use? And there's only one tool, right? The other tool is law of cosines. Okay, so if you do law of cosines, the first thing you want to find is your missing side. To do that, we'll use a squared equals b squared plus c squared minus 2bc cosine of A. If we want to solve this for A, instead of squaring it, we would square root, right? And so A will be the plus or minus square root. And if it's okay with you all, I'm going to plug in my numbers here. B is 9. C is 12. Minus 2 times 9 times 12 times the cosine of 25 degrees. Is it cold in here? No? Okay. Okay, we type that into the calculator. Bleep, blop, bloop, blop, bleep, loop, loop. You get plus, okay, well, I put plus or minus here. When you're doing the work, you do not have to do that. Because could A be a negative number? No, that would not make sense for this to be a negative measurement, right? Because it's supposed to be the side of a triangle. So in this context, it only makes sense if A is positive, and you'll get A is boot 5.407. So as you can see, starts off easy peasy, lemon squeezy. Here's the next part. Next part is also easy peasy, lemon squeezy, but it matters what order you do them in. Always. 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 All of time. Solve for the smallest angle first. I know what you're thinking. You're thinking, Mr. Lake, you told me to always solve for the largest angle first. Well, that was side, side, side. We're in a whole different town now. This is side angle side. And we always do the smallest angles first in side angle side because A is lower in the alphabet than S. So that just makes sense. The issue you'll run into if you do the largest side first is we don't know yet whether or not this is an obtuse or acute triangle, and we won't know until we find another angle. If you try to find the largest angle first, you're going to get that the sine turns out to be like a really small angle, like, or that's not true. You'll get that if you try to solve this for C first, I believe you'll get that it turns out to be like 40 degrees. But remember, that is an ambiguous case because there is another angle in quadrant 2 that's also positive at like 140 degrees, and could C be 140? Well, in this case, yeah, because 140 to 25 is less than 180. That would work, right? So you'll get two possible cases if you won't know for sure which one to do. If you do the smallest angle first, it has to be acute, right? You can't have two obtuse angles in a triangle. The largest angle is either acute or obtuse. The other two have to be acute. Does that make sense? You can't have two angles that are bigger than 90, because if you had two angles that were bigger than 90, that's past 180. That's illegal. People go to jail over that kind of stuff. We've talked about that. And it's a special jail too. It's math jail. It's the worst. They just have you do English papers all day in math jail. Nobody wants to be subjected to that. So always do the smallest angle first. All right, so if we do that, we're going to find B first. So we're going to do the sine of B over B equals the sine of A over A, which means that B is equal to the sine inverse of side B, 9, times the sine of A, 25 degrees, over side A, which we said was 5.407. And if you do that, you get 44.7 degrees. And you do not have to worry about finding, well, what's the other angle it could be in quadrant 2, because B can't be the obtuse angle. It can't. It's smaller than C. If there's an obtuse angle, it's C. So I know this is the one and only correct answer. And now I could find angle C by just subtracting. C is 180 minus 25 minus 440 minus 44.7. And if you do that, you get 110.3 degrees. So it turns out that C actually was obtuse. So if you solved it first and you didn't check for the other angle, you would have gotten that C was acute, and then subtracted to get 180 for B and got that B was the bigger angle, which actually should be a relief, because at the end of the day, you can check really easily and really fast whether or not you goofed. Is the largest angle opposite the largest side? Yes. Smallest opposite the smallest? Yes. Medium opposite the medium? Yes. If you forget this rule and do the largest angle, when you go to check, your spot check will fail. You will have these angles backwards. This one will be medium and this one will be the largest. And that you'll be like, no, that can't. Oh, yeah. Mr. Lake said always, 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 all of the time, solve for the smallest angle first, exclamation mark, exclamation mark, exclamation mark, question mark, exclamation mark. I remember him saying that. It was in that really long time where he was talking for like 10 minutes straight, and I kind of lost him at the beginning and the middle, but then I picked it back up at the end when he started talking about how I would remember this conversation that we had right now. And people say it's hard to teach. It's not hard. You just have to say a bunch of words. All right, so for side, 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 solve for biggest first. Side angle side, smallest first. How can you remember between those two? S is lighter in the alphabet than A. That's a nice little happy coincidence that hopefully can serve as a little memory trick. But again, at the end of the day, it's really impossible for you to get this wrong, because if you do the spot check, it'll catch that you goofed. And then you just go back and do the other way, right? For this one, that's not that bad. We just start over here. If you mess it up for side, 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 that is kind of annoying. You have to erase the whole thing and start all over again, which is kind of a pain. All right, questions on the example? All right. Does anybody need more time to write? All right. Then let's have you do one. And in fact, I think for Ty, I had first hour do this one, and we skipped this one because of time. But I think for Ty, we're going to do this one. Okay. Pitcher's mound on a softball field is 43 feet from home plate. Distance between the bases is 60 feet. This angle from the pitcher's mound to first base is 45 degrees. Find H. Oh, wait, this is easier. Oh, no. Whatever. Whatever. We'll do it anyway. The other one was more work than this one. I've committed. We'll do it. Okay. So first thing you have to do is solve for H, and then actually you're done with the problem. But we'll talk about how to do the rest if we cared. 3 minutes on the clock. I wonder if those are the real distances or if they just made up numbers. It is for softball, and those have pitcher's mound is closer. Which my wife tells me means that it's harder than baseball because the pitcher's mound is closer. You have less time to react. That's what she said too. Also, softball pitches, those weird me out. The windmill, people, oh, I don't think I could have my daughter be a pitcher for softball. They destroy their shoulder. Like, all of them need, like, a good portion of them need surgery for that. They have to do underhand. If you look up, and there's some, each pitcher will have their own like style of how they do that, right? And their own little stepping up and that kind of stuff. But the over the arm throw, just doing it myself, I'm like, my arm would be gone. It would just dislocate all the time. It already does kind of do that a little bit. If I had to do softball, it would just be like just hanging off the side of my body. I mean, there's a way to do it so it's not strenuous. Isn't it wild? I'm sure there's a technique that you're supposed to do that alleviates that as much as possible, but it seems like just do tennis, right? That's better. Because then you go back and you bend here, and it's just a whip that you don't have to worry. Yes, you go around, you don't get the full 180 swing. I did not know that. Congratulations. Are you in there because you like stole a base, did something bad?
It's just like all the stats.
Oh, stats.
I'm on their pitching, stolen bases.
Nice. Congratulations, sir. That's very cool. I know. It's wild. And a lot of them will like, they'll have their own way of going to it too, that sometimes adds more, like they'll wind up and then throw, and I'm like, ah. Okay. So I solve for h using the law of cosines. So if we plug in, you should get h squared equals 43 squared plus 60 squared minus 2 times 43 times 60 times the cosine of 45 degrees. To solve that for h, you just got to get rid of the squared. So we're going to square root that whole thing and get h is about 42.43 feet. Okay, if we were asked to find the missing angles P and F as well, which one do we solve for first? P or F? F. Because it's the smaller one. Good job. Oh no, connection issues. We'll just keep trying. Good job, Gavin. That's right. F. Solve for F first because it's the smallest. Use the law of signs. I don't think we need to walk through that again. Or do we want to walk through that again? Walk through that again? Yeah? Yeah? Caitlin? No? Remote people, you want to see us find angle F? They're not saying yes. All right, that's fine. If you want more, if we have time, we'll come back and do this one. I bet that we won't. So if you are a little shaky right now and you just don't want to say, Mr. Lake, I'm lost when everyone else is pretending that they have mastered it, right? Then there is this one. It's in the notes that you can look over. Practice for yourself. Also, you can, I guess, no, never mind. I take that back. Okay, last thing we're doing today then. This needs to go into your notes too, because I know you all have been dying to ask me this question. You just wanted to wait for the right time. The formula I gave you for area earlier required you to know two sides and an angle. What if you don't know two sides and an angle, Mr. Lake? What are you going to do then, buddy? Huh? Feel pretty dumb, won't you? You don't have two sides and an angle. Don't worry, I got you covered. If you know three sides, use this formula. The square root of s times the quantity s minus a times the quantity of s minus b times the quantity of s minus c, where s is a plus b plus c divided by 2. The proof, or why that formula is the way that it is, the proof of why it works is actually pretty long. It's like a page long. If you are interested, it is on page 474. If you want to prove why, why does that work the way that it does? Okay, anybody need more time to write? What? I suppose. All right, let's try a problem. All right, for this one, find the area of the triangle. All right, because I'm given no angles, I have to use Heron's area formula, which tells me that the area is equal to the square root of S times S. Okay, that's not an S. Let's try that again. S minus A times S minus B times S minus C. All right, well, I know A, B, and C. I don't know S, but I can find S really quick. S is just A plus B plus C divided by 2. So it would be 43 plus 53 plus 72 divided by 2, which is 84. Is that what you got? Do the numerator first, hit enter, then divide it by 2. All right, if we've now plugged in our numbers, the area is the square root of 84 times 84 minus 43 times 84 minus 53 times 84 minus 72. Type into the calculator and you get that the area is about 1,131.89 meters squared. If you remember back to geometry, to do this problem in geometry, what you would have had to have done is put this like on a coordinate plane and find like the rise over run. Find the perpendicular line here and where it intersects your other base, and then use the Pythagorean theorem to get the height, and then do base times height divided by 2. Or a shortcut for that was the shoelace formula, which was still a pain. Now you could do that in like, what, probably 15 seconds for this, 15 seconds to type that in, 30 seconds. Isn't that nice? Questions on the old area formula? Anybody need more time to write? Your turn. Find the area of a triangle with side lengths 5, 8, and 9. Once you have the answer, I think this is we'll be done. This will be the last thing we do today. Why are we so much faster than the first hour? I really don't know. I don't know. There are less of you. They are sleepy. They've started, most of them will bring in a blanket and a pillow, and they'll just lay down. That. But no, it's just because there's more of them. Because I'll often, in the 3-minute period, walk around and check every paper. Whereas for you all, I just call on your faces, right? And then your faces tell me if you got it or not. So that does save us a lot of time. That's why. Ah, well. Oh, here you go, Ty. Boom. we did this first, and then this second. So first thing you do is find S, plug it into this formula. Yeah. Yeah. You want a picture of that?
Right up.
Okay. It's a pretty cool formula. So it's not too bad. Actually, this is a formula I did not know existed until I taught this class. And then I now go back and teach geometry with this formula. Feel like it's easier than what they were doing. Okay. What did we get for this one?
The final answer
Final answer.
at 19.8997.
That's right. 19.9. So S, you should have gotten was 5 plus 8 plus 9 divided by 2 is 11, right? And then the area is square root of 11 times 11 minus 5 times 11 minus 8 times 11 minus 9, which if you round, your answer is 19.90. Yay. Okay. The homework 6.2 is due Monday. And then Monday, we will start vectors, which are really kind of cool. It'll feel like a kind of different, like a real hard break in the chapter. Actually, if I think I was writing this textbook, I think I would have just included these last two lessons in chapter 5 and then let vectors be its own chapter, because I mean, it's similar. You need the last stuff in order to do all the stuff that we'll do with vectors. Is that even true? I think they teach it to you in an alternative way, that you really don't need it. That is true. I don't think you need it. Yeah, this should just be a separate chapter. What is going on here? Yep. I am convinced now. Maybe that's what I'll do next year. Is I'll just include 6.1 and 6.2 in chapter 5, and then let this be its own chapter. I think that would make the test easier than what you have to do for this. But anyway, vectors are really cool. And then the chapter after that is one of my favorites, polar coordinates and graphing, because we get to graph roses and stars and other pretty stuff. It's pretty cool. All right, well, you got 7 minutes if you want to start working on the homework, or if you want to relax, that's fine too. I understand.